Let's start with time complexity. That's right. Hmm. Time complexity of an algorithm. Time complexity of the algorithm. So the total time of the program, total time of the program running consists of compile time plus learning time. T compile time plus T running time. This will be done by compiler. Compiler T running time will be done by CPU. Hmm. And from there we'll get two types of analysis to calculate to calculate time complexity. First one is a posteriori analysis. Second one is a priori analysis. So a posteriori analysis, it is the actual time analysis, time complexity analysis. Here, here we'll calculate the actual time taken by a to execute program to execute. A, a priori analysis is approximate mid time to analyze time complexity. Time complexity. This is approximate time. We are calculating the approximation time. And this is not feasible. This is feasible. From here, this is a priori is always used to calculate time complexity. Complexity because large program we don't know in large program we don't know when it will stop, means how much time it will take to execute, how much time it will take to execute. So let's take an example and see how time complexity are measured. Time complexity in a program. Time complexity in a program arises due to the loops or repetition of a same line of code over and over. All the time complexity in a program arises due to the loop, and example is for loop, while loop, do while loop, etc. Now let's take an example. Example 1. We will find the time complexity of a program. That's the main for int x equal to 0, x less than equal to n, let's say int n, x equal to n, n plus plus, for int y is equal to 0, y less than equal to n, y plus plus. Let's say print algorithms, algo. Let's take this as example. Now this part of the code, this for loop will run for n times. N times it will run for n times. And this portion of the code, this loop will also run for n times. Nested loop. This is the nested loop. Nested loop. It's also run for n times. Let's see. Let's analyze what we have for x and y. For x equal to 0, y will run for n times. For x equal to 1, and y will run for n times. Dot 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 dot. For x equal to n, it will run for n times. So the summation of time means the summation of time is equal to let's remove it. So total time, let's say total time time total is equal to summation of all times time I is equal for all I, and this instant time of y. For each instance we will calculate time total is equal to, for x equal to 0 it will give n, plus x equal to 1 it will give n, plus dot 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 dot, dot up to for n time it will give n. This is up to n times. Equal to, for n we take outside 1 plus 2, no 1 plus 1 plus 1 plus dot 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 dot, dot plus 1 equal to n into this is summation n, which is nothing but order of n square. This is the time complexity of the program. Now let's take some more examples. Example 2. Main I is equal to 1. Let's take this part is example, this part is solution. I is equal to 1, while loop. Here let's use while loop. While I less than equal to n, while I less than equal to n, I is equal to I plus 10, I is equal to I plus 5, I is equal to I plus 7. This type of problem. Let's take this type of problem. This in a loop, when if the loop is, now let's take the concept here. When the loop is running for n times, the loop is running for order of n times. So what will this signify? So let's say in this Let's take to understand this type of problem, let's break down it into simple one. This will occur, let's say, for I in I is equal to 0, I less than n, I plus plus. I is equal to x plus 10. Let's take this. Let's break it down into pieces by pieces. So while loop can be converted into for loop, and vice versa. For sake of simplicity, we took the while and converted into for to understand this. So this loop will be running by n times. This loop running time is odd n. So every time it will be x plus x plus 10, x plus 20, dot, x plus some constant into 10, sorry, x plus some constant a into 10, x plus 1 into 10, x plus 2 into 10, plus dot, x plus some constant into 10. So whenever we see this type of thing, it is increasing by 10 every time, increasing by 10 every time. So we can say the total number of time the loop will execute is equal to n by 10, because every time it is skipping 10 elements plus 10 elements every time it is skipping. So total time it will go is n by 10, and by 10 times it will execute. So if we come here, for here it will go n by 10, and for here it will go n by 5 by 10, which is nothing but n by 50, which is nothing but n by 350. This is the complexity of the program. Every time it will change. For multiplication, same goes with subtraction. But for multiplication and division, for multiplication and division, the complexity slightly changes. Now let's see how it changes. Let's say I is equal to I5 into I in the loop. So every time it will be like I by 5, then I by 25, I by 125, it is 5 square, 5 cube, like that. So it will be in log term, log base 5 into n. For multiplication division, it will go, because every time it is keeping some logarithmic, it is keeping some exponential term. So exponential term can be expressed in logarithmic series. Now let's take some other examples I have. Example, typical example, main I is equal to 2 while I less than n, I equal to I square, I equal to I part 12, I equal to I part 29. For here, let's remove this portion. Let's remove this portion and start to make it simple. Let's start. So for first, this will get executed, then this. For here, it will be log 2 into I, and for here, and then for here of this log 29. This second term will come in the first position. The power of the first will go in the second location, because after running this amount of time, this loop running this amount of time, this portion of the program will execute. This will be the time complexity, new time complexity, and together multiplying this portion, we are getting the total time complexity. So total is equal to log 29 of log 2 into n. This is the total time complexity. This type of situation. Let's say, yeah, let's take another example. Let's take another example. Main q is equal to 1 for I is equal to 1, I less than equal to n, I plus plus. P is equal to 1 for j is equal to 1, j less than is equal to p, j plus plus. J equal to 1, j less than n, j less than n, sorry. Less than j. I'm taking it from the gate solution. So gate paper, let me take it how it is given. K equal to 2k, p plus plus, for j is equal to 1, j less than equal to p, j equal to 2j, q plus plus, solution. Now for this position, equal to less than n, sorry, n, yeah, n equal to k plus plus. This will run for order of 2k is 2k log 2, and this portion will learn how it is learned. 2k, every time it will 2, and sum after 2 power k is equal to n. After sum 2 power k, it will be coming to n. Then log k is equal to taking log 2 of 2 power k is equal to log of 2 of n. So k is equal to log 2n. Means after k term it will stop, so k is equal to log 2n. After this amount of time, this program will execute. So p value will be log 2n. And for here, for next portion, this j is equal to 1, j less than j is equal to 1, j less than equal to log 2n j is equal to 2j, right? So it will be log 2 of log 2n. This is the time complexity of this loop. You want to see how? See, this portion will bring log first, and this is the condition till this portion, and p is nothing but log n, and log 2n will be up for this, up to this, for this it will run up to log time. So the total time complexity is for here n into, since these are two separate loops, it will be log 2n plus log of 2 of log of 2n. This is the total time complexity of this program. This is the total time complexity of this program. So order of n log n. So the question arises, why are you always taking the bigger one? Why are you always taking the bigger one? See, the problem, the solution is, I'm telling you, let's take a sea. This is Indian Ocean. Let's take this is an Indian Ocean. This is huge. If someone, let's say me, I am taking a bucket of water from Indian Ocean and throw it in the beach, will the water level decrease in this Indian Ocean? Answer is no. So from a huge amount of object, if you take some small portion, should it be affect any in this option? Answer is no. It will not affect, or not affect the size. Let's say if you don't get it, I'm taking for from 10 lakhs rupees. I have 10 lakh rupees. If I take 2 rupees from that, will it affect remaining ways for the 10 lakh? No. If I get 10 lakhs, I'll not consider the 2 rupees. So that's why we always take large one. We always consider the large one, not the small one. Small one are neglected. But if the question asks for total complexity, then we can't ignore. Let's take some another example. Let's take another example. Let's take another example. Main for I is equal to 1, I less than equal to n, I plus plus, j is equal to 1, while j less than equal to n, j is equal to j plus I. Give questions. So let's first take this portion. This it will be option j is till n, right? Means it will execute up to n times. So this portion will get executed till n by I time. I, 2i, 3i, like that. If we go, means every time it will be skipping by I. So total number of time it will execute is this amount of time. Now this loop will run for n times, but the situation has changed now. Here this portion depends on I. So we'll take I'll take ij. For I is equal to 1, this will run for n times. I is equal to 2, it will run for n by 2 times. For I is equal to 3, it will run by n by 3 times, like that, till it will run for 1 times. Then total time it will be n plus n by 2 plus n by 3 plus till n, n by n, n by n. Let's take out n. 1 plus 1 by 2 plus 1 by 3 plus up to 1 by n times, which is nothing but n into log n, log n. It's much log n. Answer will be n log n times order of n log n. Hope you got up to this portion. Thank you.